Hello YouTube, this time I'm making a video almost in the middle of the week. Anyway, I did show you this gorgeous 3.5 inch 480 by 320 pixel capacitive touchscreen display that was sent to me by Makerfabs. Thank you very much again. And I talked about this before in my previous video, so I won't go into that. What I did say is that I want to design a 3D printed case for it, and I actually would love that case to be milled out of solid piece of aluminum. So speaking of aluminum, I have this enclosure here, which I did buy years ago when I made my video with the 6 OLED displays that you might have seen. And initially I wanted to put that in here, and to protect the OLED displays, I even got a screen protector, and this is from a, I guess you probably can tell by the big round hole here. This is, I think it was iPhone 4 or iPhone 4S. I'm not sure if they're the same size, but it's an older model phone, and I wanted to cut this up. I never cut up, this is supposedly glass, I don't know, sounds like plastic, but I wanted to cut this and put it behind the case as a screen and a screen protector. So while thinking about the display, this thing came to my mind because I had it stashed somewhere, and actually it would fit quite nicely in here size wise. But I mean, you see, you have, this thing is more than twice as thick as it needs to be. And since I didn't want to end up buying these cases, and the very hard part would be to mill out the, well, not hard, but you would have to mill out the square hole, although obviously the case I designed was much more difficult to mill. Well, CNC milled, you're not doing it by hand, but anyway, it's just more, has many more shapes anyway. But there was also one problem with this all aluminum case. Obviously, this is the ESP32 module, which has Wi-Fi and Bluetooth. What would happen if I put this in here? I would lose all wireless connectivity to it. So that was a no-go as well. So anyway, I scrapped the idea. I will save this for another project if I ever do it with it. But I did like the screen protector because it is exactly the same height as the display. There's maybe 0.5 millimeter wider than the display, but I mean, that's just doesn't matter. And I would have just find a way to cut this at the edges, and since my case opening will be just a little bigger than the actual display area of the display, I still have some room here for, I mean, I don't know how the edges will end up. This is probably laser cut, so I will cut this by knife. I mean, just score it and then try to break it. I don't know if it's gonna break, if it's gonna shatter, or if it's just gonna break like regular glass on that scar line. So I will try that. I have nothing to lose. I mean, these things are cheap these days, especially if you get it from an older phone. So anyway, that was the idea. So I will use this as well. Not that it needs to, because it obviously, I'm not sure if this capacitive touch screen, the overlay, is actually glass or not, and I'm not sure how hard it is or how easy it would get scratched. But I do not want to take chances, and I rather put a a dollar screen protector on front of it, and if this gets scratched up, you can just open the enclosure, take it out, exchange it, put it back together, and you will always have your pristine display. You could also, of course, get screen protector foils that you can cut easier, but those are easier to scratch, and this has a pretty good visibility even though both foils are on here, so I'm sure this will be optically better than a foil that you could put on here. So anyway, and I also did try some other codes. I did find, and I found it before but I never used it much, the TFT ESPI library that now supports this screen as well. And I put a demo code on here because I wanted to show you the screen again and how it does look like. As I said, this is just a demo code, and you can see the colors are pretty nice. Viewing angles are okay, and it's pretty fast. So let me upload another code. I'm using the Arduino IDE with the ESP32 board. Boards uploaded to it in the boards manager, and let me just upload this code and show you a different screen with different font sizes. I won't go through all the example codes because there are just too many, but I just wanted to show you two of them. So now it's compiling the sketch, and I will show you the enclosure that I designed in a few minutes. It came out, if I say so myself, pretty great. So I do like it, and I will also tell you how I solved the wireless issue. So it did compile almost. I wish it would be faster because it does take quite some time. Okay, now it's connecting and uploading. As you see, the screen turned white. Don't mind the colors here because my overhead LED lights make it a mess. So this is how the colors look. This is a rainbow code with different font sizes and background colors and transparent white on black, transparent and whatnot. So I think here the colors change because on the fonts doesn't change much, but you can see how fast it does refresh the screen. Obviously it's the ESP32, so anyway, this is it. Here you can see the beautiful colors this display can display. So now let me show you what I did design. I did design this with Tinkercad online, and then I imported it into what's it called, OpenSCAD, and here I can show you the case that I designed. So this is the front. I'm sorry about the, I don't know where the hell I'm going. Let me get something pointy. This will do. So I did design, this is the front opening obviously, and it does have a beveled edge also. It's not just square, straight cut down. It does have this bevel that you can see here. You can see up here, and it has the, actually what I liked a lot about my H.E.D.S.Trek is the 45-degree angle corners like I have on all of my products now. You can see here I used to do it round, now I'm doing it with the angles, and it just looks more I would say industrial design, although it's probably not, but it does look better, I think. So it has the angles. This is the side view. Let me try to zoom in a little bit more. This is the side view. And I didn't want to have any openings on the sides. Even though, if you do want to use the micro SD card, you would need a slot on the side, and as well for the micro Type C, USB Type C connector. So those I did not put in here yet. Excuse me. I will probably 3D print this if I can make sure that my filament will be enough to print it, and will make the openings on the 3D file. But on the aluminum I don't want any openings, and I will tell you my solution for that as well. So now let's take a look at the back of this. So as you can see, you have this is the exact opening, not exact, it's about 1 millimeter bigger than the viewable area on the display. So you will get a 1 millimeter black stripe here, I mean visible of the display, and the rest will be hidden underneath this lip here. And the whole width, the internal width, is about exactly 90 millimeters. So this fit in there, this will fit in there with no room to wiggle. What I will do is excuse me, let me take a sip of my juice. What I will do is cut off the mounting tabs here. I tell you why also in a second. I will cut the mounting tabs here, because once this is in here, obviously you would first put the screen protector in here, and then you put the display in here. And since it can go nowhere, it could be glued in or just hold there by tight fit. And I didn't want to use these tabs because that would make the enclosure just higher than more than what I wanted. So that's why I did not do it. And I'm thinking of designing a PCB myself, also with the ESP, with some other added features to it, and also get a display like this. Although I have to say, this display is not an IPS display, it's a regular TFT display, and I found a display with the exact same capacitive touch. They also come with resistive, but I like the capacitive much better. And I found the ISP display, same pixel, again with 480 by 320 pixel, same size, and with this gorgeous front panel. And I will order that and then make my own version of this board. So that's why I wasn't worried about these tabs, and there's no need to screw this down with 4 screws into this case, obviously. So that's why I didn't take this into account, and I will just cut it off if I'm gonna put this into this case. So, and you can see here there is a edge, well, there is, how you call it, indention, no, something different, doesn't matter. So there is a lip around the outer edge where the back panel will fit in, and it has the same depth, the same size or the same thickness as the back panel. And now the clue is the back panel. This is it, very simple, same shape, 6 mounting screws. I also again did put the screws only on the bottom and the top and not on the side, because I want this to be as small as possible and kind of centered around the display itself. And this back piece will be, you guessed it maybe, carbon fiber. So now it will not only look great, just imagine you have this black display, you have anodized aluminum frame and the carbon fiber back. So I mean, I think it will look gorgeous. So let me know if you think differently, but that's my idea. So the carbon fiber part, the back part, is the easiest. And then I thought, if I'm going to design a PCB myself, I will use the vertical USB Type-C connector like I use on my CAN gauge, and just make a cutout like this in the carbon fiber and have the connector come out straight off the back. So that would mean you can put it on the table anywhere like you want. You can mount it anywhere and have the wire coming out the back. Of course, since you have Type-C, there are many cables, wires out there, like this one for example, and you have angled connectors like this. And the beauty of angled connectors is that you can put it this way or this way. So you can go out left or right. And there's even angled connectors where the cable comes out this way, so you could have the wire coming out the bottom or the top in case you mount this somewhere or in your car, for example, where the sun visor is. You can go with the wire going up, or just use a straight plug and go straight out the back. So that's the also advantage compared to USB to micro USB, which I will go away from, and all my boards will be redesigned with Type-C connectors. So that is one possibility. And then I was charging up my smartwatch that I use as a remote for my CAN gauge, and as you know, these have the magnetic connectors, and that's what I thought. Why not make this with a magnetic connector for these type of cables that are regular USB data cables? So that would make it even nicer, I think. You would not have a hole to get any debris in there. I mean, not that you're gonna do it, but I mean, it will be cleaner. So the back would look like this. It would have 4 pins. The pogo pins are on the plug, so these are the pogo pins with springs, and on this side you just need connectors, and I did find connectors like that you can use. And then I of course had to try the carbon fiber with magnets. Is the carbon fiber, hold on, let me put this down. Okay, we got more light. And here you can see magnets on the carbon fiber, and it does hold. So since carbon fiber is conductive, it's no good for touch sensors, for example. I cannot put any touch sensors behind this. And obviously in this case I don't need any touch sensors because I have a touch screen. So all the need for touch sensors will be gone, and I could just have the carbon fiber have 4 holes for the pins, for the connection pins, and then just glue very easily. Just take the magnets, stick them on here, and these are now different. I have 2mm and 3mm magnets here. This is a double, so this is a 2mm height, this is 3mm height, and 3mm in diameter. I could just put the magnets on here like that, and then just glue them in place. And since they are attracted from the other side, and if you pull it you have still the carbon fiber in between, there is no way they will go anywhere. So I just need 4 small holes, put the contacts in, solder them with wires to the board. I could then even use this board. Technically I don't have to use the Type-C connector, I just have to use the connection points of the USB connector and have a magnetic connector on the back of the enclosure gauge or whatever I'm gonna do with it. I still haven't made up my mind yet what it's gonna be. But I mean, with this you have many possibilities. And as you know, you might have seen in my first video I showed you there is a camera attached to this side, and that camera I can just flip to the back and have a hole to the corresponding space in the carbon fiber and have a camera going out the back. To the front it will not work because then I have to make the case way bigger to have the camera facing the front, but it will be easy to just have it facing the back. So this is it, guys. So this is my idea and my version of the gauge. I still think it will just look great. It will feel great in the hand because of the beveled edges. It will not be clumsy as this, especially like on this. I mean, it has some radius here, but I mean, this is way too thick. This thing is only 12 millimeters in height, and I could go even lower if I wanted to, because this thing is like 6 or 7 millimeters deep only. So this is my idea. I will share this design on my Tinkercad, where you can go and download it. You can go print it out. I will probably make 3 versions of it. One will be like this with no openings on the sides because I want to use it that way. I will make one with just the USB connector opening, so you can plug in your USB Type-C connector plug, and I will make a version where you can access the micro SD card from the outside in case you do use it. And if you, well, I could make 2 versions of the back plate, which you could technically 3D print as well. What I did is on here, since I'm thinking of aluminum here, these holes are 1.6 millimeters in diameter, and that's the size that you need to tap for M2 screws, these little guys here. So that one will just tap directly in it. If you use it, if you 3D print it, you could use the, hold on a second, I have it here. Let me move this to the bottom. You could use these nuts. These are nuts that you use your soldering iron and press into the ABS, which I did in my previous V-gauge cases enclosures. This is it for 2 millimeters, and you squish this in. It gets, I mean, the plastic melts, and this holds in there, and then there is no way that you mess up the thread in the plastic. Well, I'm using ABS, but even though if it's ABS, if you screw it directly into the ABS, it will sooner or later wear out. Obviously this you wouldn't need to open all the time, but I just want to make it last longer. So on the ABS it will have slightly bigger holes, so you can press these guys in. So it's gonna be 2 versions, one for ABS and one for milling out of aluminum. I do have a CNC mill. I'm just not sure if it's strong enough to mill this thing. It is, oh, by the way, 100 millimeters wide and 70 millimeters high, and like I said, 12 millimeters deep. I will look for a company because also time is money. I mean, if I want to make this myself, it's gonna take me a couple of days, and then I rather pay a company to have this professionally milled out of aluminum, and rather pay them than instead of using my time to trying to make it myself. And since it's, I mean, CNC, if I give them this file, it will come out exactly as you can see here. So let me know if you like it or not. The only one thing that I will miss and haven't incorporated in this design is, you guessed it, NeoPixels. So I am not sure if I'm gonna add it. I could technically make this a little higher. I would do it on both sides to have it symmetric. Make it a little higher, and then I could actually use the side emitting NeoPixels that I use here, that are technically only 2 millimeters high. So it is still an option. I could do it, but I would say on the first version I will do it without NeoPixels and might add it later on. So now I will try to source a company who can mill this for me, preferably not for an arm and a leg, but something payable. Of course it will still cost a lot, because I mean they have those tooling charges and whatnot. I mean they're gonna have, it's not that complicated, I mean really not. The only one issue I see is the beveled edge, the inside edge, because if you try to mill this, first of all, if it would be even straight, you will get a, depending on the bit they are using, you will get a radius here. It will never be a 90-degree radius or 90-degree corner. It will be a radius. So what I would do probably is just have them milled out straight and then bevel the edges myself, because if I tell them to bevel the edges, I don't know, that's gonna get expensive. But if they just cut this out with the smallest mill they can use, so I have a smaller radius here, although it doesn't matter, even if I have a radius here, I have room, or I will have room to file this down. So that I would do by hand. I would probably design some kind of holder for it to get the same angle all the way, so it will not be like this, but on a straight line, like the knife sharpeners or knife makers do. They have jigs where they can file the edge to a certain degree all the time. I mean it's not gonna change. So that work I would do, because otherwise I just have to take this and put the display in, screw the back on, and be done with it. And do not forget time. I mean all the do-it-yourselfers out there, they know how much time stuff like this takes, and time is money. I mean some people think this thing happens by themselves and it doesn't take time and whatnot, and I have also people complaining, yeah, you charge too much or whatever. And then I say, well, I guess you're working for free. If you work for free for somebody else and time doesn't matter, you work for me. I sent you all my stuff and you can do it for me. And then I never hear from them again. So time is money, definitely. Also, if I want to make this myself, it would take me 3-4 days. I don't know how long. And if I would happen to sell like 10 or 20 of them, I mean, that's a lot of time right there. But if I order it, at least tooling charges, they charge you only once, and then for the future parts it will cost you less. So I am prepared, although money wise it doesn't look good, but I am prepared to pay more upfront if I know it's gonna, I know it's gonna look great, but I am prepared to go that step. I could technically just 3D print this and be done with. I could even technically just 3D print the frame itself with the edge here and then put a carbon fiber on the top as well, on the front. So I could do that as well, engine, and then have a 3D printed frame. But I want to go aluminum with this. I want that look, the feel of aluminum. I like it, I love it. And even this simple vise that I have, this is one of my favorite tools here. And also aluminum, as you see, this is anodized in clear. You could anodize it in red, you could make different colors. And the anodizing, I know how it's done. I never did it myself till now, but the anodizing I could do myself. I mean, if it's just a few dollars, let me say it like that, if it's a few dollars, I would have them anodize it in natural first by the company who's gonna CNC mill it, and later on maybe get some how you call it, well, not anodized aluminum, and then anodize it myself in different colors, because that I think would look nice too. So anyway, long story short, I'm sorry if you're still with me. Thank you very much for staying with me. As I said, let me know if you like it, and I will upload this on Thingiverse and share it there. And if you like, you can 3D print it. If it would be open SCAD file, you could technically take this and just resize it to whatever you need, but I did use Tinkercad, so actually you can still use OpenSCAD, I think, to manipulate the sizes, but I won't go into that. This is a case for this display that you can get at Makerfabs. This is like, I think, $35, and it's a great starting point if you have any ideas that you want to do with this. I mean, this is ready made. I mean, this saves you a lot of time, and I actually wanted to use this to make a product out of it, which I could just buy, upload my code to it, put it in an enclosure, and be done with it. Because anything I make by hand, it takes a lot of time. It does take a lot of time. I mean, even here's something like this, which is the clock and GPS. Just to put this together, it takes almost an hour. I mean, just mechanically. You won't believe it, trust me. Well, maybe not an hour, but it does take some time. And I'm not talking about putting solder paste on the PCB, placing the parts, reflowing and whatnot. That's all separate. So this would actually save me a lot of time. And I said before, I say it again, time is money, especially if you have to make a few of them. So anyway, this is it. A big thanks again to Makerfabs for sending me this. And this, I haven't made a video about this much, about this. I just showed it, and I will do a video about this as well. So, but this video was about this and the enclosure, and sorry if I say it too much, but I think that enclosure looks great and this would really look nice. Anyway, thanks for watching, and also big thank you to my still eight Patreon supporters. Every little helps, and also by using my Banggood affiliate links, that does help a little bit as well. So this is it. Thanks for watching and take care, everybody.